Good morning everybody. So in this video I am going to present a lecture on relation between beta and gamma function. So this is a video lecture for the program BSc, subject Mathematics, semester 5, then session 37. So let us start relation between beta and gamma function. So this is the learning objective. These are the course outcomes. So these are the prerequisites: differentiation, basic rules of differentiation, and integration. So let us start relation between gamma and beta function. So from the definition of gamma function, we have gamma of m is equal to integration from 0 to infinity e raised to minus x raised to m minus 1 dx. Now call this equation as 1. Now in this we substitute x equal to lambda y. Now we differentiate, so dx becomes lambda into dy. Now as x tends to 0, then y also 0. As x tends to infinity, y also tends to infinity. So therefore with this substitution, the equation 1 becomes gamma of m is equal to integration from 0 to infinity e raised to, we have substituted x as lambda y, e raised to minus lambda y into x is again we have substituted as lambda y, so this becomes lambda raised to m into y raised to m minus 1 dy. Okay, then multiplying both sides by e raised to minus lambda into lambda raised to n minus 1 and integrating with respect to lambda between the limits 0 to infinity, then we get gamma of m into integration from 0 to infinity e raised to minus lambda into lambda raised to n minus 1 d lambda, which is equal to integration from 0 to infinity, again integration from 0 to infinity e raised to minus lambda into y plus 1 into lambda raised to m plus n minus 1 into d lambda, then y raised to m minus 1, close the bracket, then y raised to m minus 1 dy. Now here put t is equal to lambda into y plus 1, so that as lambda tends to 0, t is also 0, as lambda tends to infinity, t tends to infinity. So with this it becomes gamma of m, this is the gamma of n, which is equal to integration from 0 to infinity, e raised to, now this one we have treated as t, e raised to minus t, then this is again t, then t raised to m plus n minus 1, then dt, then y raised to m minus 1 divided by y raised to m plus 1 dy. So which again gives integration from 0 to infinity. When we integrate this equation, we get this one with respect to dy. So which is equal to taking gamma of n plus 1 outside the integral sign, then integrate remaining terms 0 to infinity y raised to m minus 1 by y raised to m plus 1 dy, which gives gamma of m plus n, which is nothing but beta of mn. So therefore gamma of m into gamma of n is equal to gamma of m plus n into beta of mn, or beta of mn is equal to gamma of m into gamma of n divided by gamma of m plus n. So which gives beta of mn is equal to gamma of m into gamma of n divided by gamma of m plus n, okay, gamma of m plus n. So this is the relation between beta and gamma function. So these are the some problems which I have left exercise for you. So beta of mn is equal to a m into n divided by m plus n, gamma of m into gamma of n divided by m plus n, c gamma of m into gamma of n divided by gamma of m plus n, d none. Then second one we have beta of 1 by 2 comma 1 by 2 is equal to first pi, second pi by 2, third root pi, d none. Next third we have gamma of 1 by 4 into gamma of 3 by 4 is equal to pi, second option pi by 2 into gamma, third option gamma pi by root 2, then fourth none. Next fourth problem we have the value of gamma of minus 1 by 2 is First option is root pi, second is minus 2 root pi, third is root pi by 2, then fourth one is none. Then fifth problem we have gamma of 1 plus n into gamma of 1 minus n is equal to, first one gamma of 1 minus n square, B second option is sin n pi, C n pi by sin n pi, D none. So these are the some references books I have used. So with this I conclude this session and continue in the next one. Thank you.